Hi there, today we're going to do the Interactive Advanced Concept 5. This is the presentation where we're going to clean a penny using a solution. So I'm going to turn the camera here so we can sort of watch the process happen. I've got here white vinegar and salt. I've got a very dirty penny. As you can see, very dark on both sides, as well as a bolt here. So first things first, we're going to take the penny. Oops. Just get my camera set up here. And we're going to put the penny into the solution and we're going to watch it get clean. So right away we can see that the penny is getting shinier. It's losing some of that dark color. Oops. A little bit difficult to see on camera, but once we pull it out of the mixture, we should be able to see how much it's changed. So we'll give it a few more seconds here. All right, let's fish it out. So even in just a couple seconds, we can see that it's a lot cleaner than it is when it went in. Not 100%, but still much shinier, almost new. Now let's see what happens when we put in our bolt. So this should be changing colors. But I'm not really seeing much change. It might be slightly dirtier, a little bit dingier than when it went in, but very, very slightly. So let me straighten this back up. So what is causing this reaction? Basically what's happening here is this reaction. As we can see here, we have sodium chloride, that's the salt, and then we have the acetic acid here, which is the vinegar. So the sodium ions in the salt basically force a shift in the equilibrium of the acid dissociation. It forces it, or it shifts it to the right, and that means that we get these products, which is sodium acetate and hydrochloric acid. The hydrochloric acid is what we see cleaning the penny. This is a strong acid, and that's why we see such a swift reaction. As we can see from these two equations here, the copper oxide, which was the dark film that we saw on the penny at the beginning of the experiment, can react with the acetic acid with the vinegar to produce water and a copper salt, just like the copper oxide can react with the hydrochloric acid to produce water and a copper salt. However, the hydrochloric acid is going to be stronger and it's going to produce a much quicker reaction than if we had done it with just vinegar. So essentially, that was why we added the salt to the vinegar, was to speed up the process so that we could watch the experiment happen very quickly. This is also important here because we know that in the final solution we have this copper salt, and having copper salt in the solution means that that is what is causing our bolt to get a little bit dirty. It's got like a little bit of like a darker sort of smudge on it now. And that's basically the copper salt in the solution sticking on to our bolt. So that's what's causing that. If we left the penny out for long enough, we would actually see a sort of blue-green patina forming on the penny. This would be caused by the chlorine in the salt, the oxygen in the air, and the oxygen in the air reacting with the copper in the penny. Because once we've removed the sort of protective surface of the copper oxide, the copper can then react to other things in its environment, which would be the chlorine and the oxygen in the air. The chlorine that came from the salt that is still on top of the penny. The most famous example of this patina, this green-blue patina that forms, is of course the Statue of Liberty, the beautiful blue-green color that we know it has today and is very famous for is actually this patina caused by this reaction. In fact, if you read old newspapers from New York, you'll see the citizens of New York were complaining about how ugly and discolored the Statue of Liberty was becoming, and there was actually a very big push to have it cleaned, to have this patina removed. Thankfully, they did not, and we now can see its beautiful color all the time, which is excellent. The patina also protects the copper. It creates a shell so that the copper cannot become corroded further. So if you did remove the patina from the Statue of Liberty or from this penny, then it could cause the copper to break down even further. So leave it on and we can enjoy the beautiful color for quite a bit longer. Thanks.